Okay, so I should have brought in a little example here, but in this case, you can get these little flying pigs and they push forward. And what happens is you hang it from the ceiling and it moves in a circle and it makes like a cone. Okay. So in this case, the question is, if I know if it makes a 35-degree angle with the horizon, the vertical, how fast would it have to be going? I give it the mass, I give it the length of the string. So let's just start with a free body diagram for the pig right here. So here's the pig. I have the gravitational force, I have the tension in the string, and that's it. I don't have anything else. Okay. But I do know that if this is my x direction, I know the change momentum in the x direction. So I could say F net y is going to be equal to, let's see, this angle, that's theta, so this is also theta. It's going to be t cosine theta minus mg equals 0. The net force in the y direction has to be 0 because it's not changing its vertical momentum. So, but I don't know t. I do know theta. Okay. So I could use that to find t. But that's not what I want. I want to find the velocity. So let's look at F net in the x direction. So this is going to be equal to a component of the tension, t sine theta, because look, see, that's my opposite for this right triangle, right? So opposite is sine. So don't fall into the trap saying, oh, it's x, it's cosine. No, that's not true here. So that's in the x direction, and that's the only force in the x direction. And that's going to be equal to the change momentum. For a circular moving object, that's going to be m v squared over r. So couldn't I just use t here and plug it in right there? No. Caught you. Because we don't have r. Okay? I have the length of the string, but I don't have this distance r. So, but you see here I have a right triangle. I know angle theta, I know L, so r is going to be L sine theta. So now let's solve this one for t. I get t equals mg over cosine theta. And I plug that in down here and solve for v squared. V squared is going to be equal to t, which is mg over cosine theta, times sine theta. Now I have to divide by the mass. And then I have to multiply by r, which is L sine theta. So I get sine squared theta L. So now I can just plug in, I know the mass, which cancels anyway. It's just going to be g sine squared theta L over cosine theta. Let's just check and make sure that things are working correctly. Does it have the right units? G is in newtons per kilogram, which is also meters per second squared. Oh, this is squared. Meters per second squared times meters is meters squared per second squared. So that's good. Okay, now what if I have a smaller angle down like this? Then it won't have to go as fast. And so you can convince yourself that that actually is true. And also the same is true if I have a longer string, it's going to have to go faster. Okay. So I'm not going to put in the numbers after my last video I failed, but you can put in the numbers for G and L and theta, and you can get the answer.